All right. Okay, so let's get started. Today's webinar introduces OPC UA and how it enables connectivity at the edge of the connected factory at the equipment level. Costantino will demonstrate the use of OPC UA to seamlessly enable plant-level edge analytics, real-time control, and cloud data consolidation for enterprise-wide decision-making and operations management. There's a lot of talk today about the cloud, but Costantino also show how the criticality and challenges and opportunity at the edge, which in a lot of ways is where the action begins and ends. Where this is, although OPC UA offers an excellent, secure, and Industry 4.0 client interface to the cloud, it's just as applicable and valuable as interface standard inside the four walls of the factory. Microsoft recognizes this as well, as they've come out with a on-premise version of Azure. Beyond is co-sponsoring this webinar with the OPC Foundation, as we work very closely with the Foundation to help members and other companies to add OPC UA to their products and solutions. This will help provide in the form of, the 5-step process, which we'll be presenting later in the webinar. We have 3 speakers today, as shown on the screen. Thomas Burke is President and Executive Director at the OPC Foundation. Myself, and Costantino Pipero, who's the CTO at Beyond. So we have, oh, sorry. We have 4 topics, well, 3 topics really. We have the OPC UA vision that'll be presented by Tom Burke. We have the OPC UA, the connected factory, the demonstration that will be presented by Costantino Pipero. And as mentioned, I will be presenting the 5-step OPC UA adoption process. And we're going to leave probably 15 minutes, hopefully, at the end for answering all your questions. So with that, I'll turn it over to Tom to present the overview.
Good morning, everyone. Thank you for taking time out from your busy day. This is an exciting opportunity with OPC UA, and I'm pleased to be partnering with Beyond to talk about the value proposition of OPC UA and the exciting things that we are doing with the edge and the connected factory. Up here right now, there is a video that I'm about to run, which basically is up on our YouTube channel, the OPC Foundation. And this shows basically in 60 seconds what the power of the OPC UA technology is. And it should play right now.
What is OPC? OPC UA is an open standard that specifies information exchange for industrial communication, particularly on devices within machines, between machines, and from machines to systems in a convergence of IT and OT. It can be used with any software platform, Windows, Linux, Mac, Android, well, you get the picture. And this makes OPC UA scalable, from minimal embedded controllers to massive cloud infrastructures, even mobile devices. OPC UA is equally suited in a closed network or utilized via the internet. Don't worry though, security is baked into the protocol for access control, authentication, and encryption. Because of its flexibility, OPC UA has been widely adopted in industries like automotive, food and beverage, oil and gas, energy and utilities, packaging, building automation, and so on. So, as manufacturing moves into the industrial Internet of Things, Industry 4.0 realm, OPC UA is already poised to fulfill the requirements.
Okay. And the music continues to go on. So these videos are available on the OPC Foundation YouTube channel, and it's a quick introduction to what OPC UA is. From a foundation perspective, we started UA in 2004. Obviously, the OPC started in 1995. And one of the significant things is that we are a very internationally focused organization, really driving interoperability and information integration from really the sensors to the cloud. We have offices in North America and Arizona. We have offices in Europe, Japan, and in China, and we are about to open up offices in Korea and India. And I'll talk a little bit more later on about that. Probably the most significant thing is the international presence of OPC and how the board of directors is actually structured. So, interesting enough, we have a lot of small companies, right, that are members of the board of directors, including both OT and IT companies. And the whole concept of where we're going with OPC UA, and being embedded, and the importance of integration with the IT and the cloud is represented by small companies like Microsoft and SAP being on the board of directors. So we joke about that, but these companies are really the driving force behind interoperability and information integration. So a lot of things are happening in the world, and everybody and their brother is talking about IIoT and IoT and M2M, and everybody has a different, definition of what they are, and everyone's talking about, well, yeah, we have IIoT-based products. But one of the things that we've discovered working with a lot of the suppliers and working with a lot of the end users is that the reality is that there's not a lot of interoperability with IIoT. You can have connectivity, but connectivity isn't about information integration between disparate applications and devices. And so what OPC UA is doing is actually working with all the IoT protocols, and we're working to address basically a complete information integration interoperability strategy that really provides interoperability for the whole IIoT world. And that's what we're going to be talking a lot about today. So if you think about what is OPC UA, really the benefits of the technology in comparison to where we were with the Microsoft COM and DCOM OPC Classic was basically we expanded and we unified all the specifications where we had data access and alarms and history. And the concept is we've allowed our suppliers to easily build an OPC server and actually take a lot of the legacy applications that were built in the past and now be able to interoperate successfully with OPC UA. And Kaz will talk a lot about that. The other thing is OPC UA is all about platform independence, particularly, and even with Microsoft. Microsoft recognizes the value of other platforms and interoperability. So what we've done is we've got a strategy where OPC UA is actually resident and actually runs on many different operating systems and different devices, which really allows us to embrace the embedded world all the way up to the cloud. We've developed a lot of different technology in C++ and Java and .NET, along with other things, and Kaz will talk a little bit later on how you can take advantage of that technology. From a scalability perspective, we're preaching the whole message of the embedded world to the cloud and how all that works. We're truly, again, we're not only operating system independent, we're hardware independent. We're leveraging all these standard IoT protocols, right, to be part and binding into the system. And we build lots of different languages and APIs for advanced interoperability with a truly scalable architecture. Security is also one of the biggest things that we recognize is lacking in simple connectivity. So OPC UA actually is standardizing on the message on the wire, and what we've done is we've actually provided a very rich web standards for security. We're actually securing the network traffic. We've got some videos and things, and there's a lot of specifications that talk about this. We didn't invent it. We begged, borrowed, and stealed it, but it truly is secure, and we've got very good recognition and endorsement from many organizations in security. The other thing that I was very focused on is how did we make sure we had reliability built into the architecture, right? In a lot of cases, you know, people say, well, you'll just get the value the next time. That's unacceptable. We have to have, you know, ability to have reliability built into the architecture. We've deliberately built protocols in from a client and server's perspective with complete acknowledgement. Most importantly, we've got the ability to have fast recovery in the case of failures of the network communication. What we've also done, and we're talking about this with our collaborations, is we've unified our data model. So with classic OPC, we basically address the things of process data and alarms and history, and the whole concept was, you know, taking this and coming up with, you know, standards where everyone would agree to them. Well, now what we've also done is with OPC UA, we actually separated out the data from the services, and we provided a whole architecture that really allows for streamless interoperability, allowing us to plug in complex information models from other organizations. And with that, I talk about the complex data modeling for a reason. So now what can happen is OPC products can actually recognize and represent a lot of the complex systems because of the OPC UA rich information model. We provide a complete way of looking at both the data and the metadata, and actually having this down to the object level at the various lowest level, and also being secure. This is a very important part as we try and we move, essentially advancing the state of the art to assess and provide information up to the cloud. You don't necessarily want the raw data, you want information. And this is a very good streamless way for us to model other organizations' information. In addition to that, we've built in a architecture that allows machine-to-machine communication where you can actually do invocation of application. So this is a big thing where the client can connect up to the server, discover what the methods are or the different applications are that they can actually invoke. And this allows a very streamlined communication and state model to really allow, you know, not only data, but allow programmatic control. And this is built into the OPC UA architecture deliberately. The other thing is we talk about the performance. Well, with everything we're doing with security and all this rich feature functionality, performance has to suffer. Well, the reality is that's furthest from the truth, because what we're doing is deliberately, right, it's been architected for speed and network performance. We've been able to test, and we can do 1 million data points per second. Our biggest problem is the server can serve data faster than a client can consume it because of all the different technologies and protocols we're building into the architecture. Vertical integration is a key strategy with OPC UA. With classic OPC, essentially you connect it up to the server, you're able to get data from the different devices, and you'd be able to visualize it. But with OPC UA, it's all about actually providing and consuming data and turning it into information and passing it up to the next level. And as you can see in the architecture I've drawn here, the concept is a client connects down to the plant network, connects up to a UA server, and then it essentially becomes a server serving up information up to the operation network, and the same goes true up into the enterprise. So when we're starting to talk about taking sensor data and putting into the cloud, what we're really talking about is taking the metadata and taking this data and looking and doing the analytics and having these different applications in the vertical integration pyramid, essentially providing the information into the cloud about the different devices. So it's not about the raw data. You can have the raw data in the cloud, but more importantly, it's about information and being able to support this in a seamless fashion. The next slide shows the various collaborations that we have. The biggest challenge we have is the amount of organizations we're actually partnering with. And this is very difficult for us to keep up to date because of this, but the important thing is we're not just industrial automation anymore. We support all the field bus networks, we support building automation, right? We're doing things specifically related to, you know, the pharmaceutical, and these are all very important things for a variety of industries. So with that, I'm running out of time. I want to turn it over to Kaz, who's going to talk about OPC UA at the edge of the connected factory and how all the OPC UA technology has become the solution and infrastructure for information integration.
Thank you, Tom, and good day, everyone. So the next set of slides, I have a couple of slides of presentation. My name is Costantino Pipero, and it's about the new architectures. We heard about the cloud integration, and edge configuration, fogs, all kind of aspects of weather manifestations. The slide diagram that we see here, it's a representation of the Industry 4.0 RAMI architecture, in which the OPC UA is considered the only valid communication protocol to date to comply with Industry 4.0 requirements. And there's a reason for it, for all the things that Thomas just explained. The one aspect of it is that the OPC UA encompasses the transportation of data back and forth to different layers of the enterprise integration, from the sensors all the way to business level systems. The specific demonstration today addresses the new features offered by the Azure cloud implementation. You know, there's a few players in the market, and clearly Microsoft is one of the strongest with Azure service stack, and they made a lot of investment in the industrial automation space. Microsoft is now on the board of OPC Foundation, and in the last few years, literally few years, they contributed 4 million lines of code into the OPC UA Foundation stacks. And that's very, very important, because we're talking about artifacts that deal with all aspects of integration, from security to data modeling to communication. In this particular diagram, we see the life cycle of the information as it travels from the plant, or the machine, in fact, all the way to the cloud analytics. Now, the one aspect that I would like to highlight is that it's relatively easy, and there's a number of solutions that allow the information to travel in one direction, and for a system to communicate data from the sensor at this level to, say, a consumer at this level, a mobile consumer, and performing some analytics in between, massaging and aggregating the information to suit specific decision support system. But the challenge when it comes with the process automation is that information is not that asynchronous, and the particular use case for some of you are definitely familiar, and I see some names that I know, with the SCADA solutions, with alarms. An alarm is a piece of information that happens at the device level, at the control system level. And at that point, some decision has to be taken. Even a simple acknowledgement of the alarm needs to happen. And this piece of information is statefully waiting for some further action to be taken. And sometimes the action can be taken at this stage, which is on a plant level SCADA system. But it can also be conveyed to a system that can aggregate that information to some other decision steps, so that a decision can be taken at this level, say to a mobile user who acknowledges an alarm, and eventually that has to communicate back to the provider of the alarm. That is not easy. That is not easy in a typically and traditionally asynchronous environment like a cloud integration. Moreover, we are talking about doing so in a secure and reliable environment. The communication has to have resiliency, and that's what one of the features of OPC UA. It has to be discoverable. The consumer at this level, the mobile consumer, doesn't have to know the intricacies of OPC UA. Has to be able to discover the information. That's one of the features of OPC UA. But at this point, the system doesn't know what protocol is being used. It should be transparent. And having that bidirectionality of discovery, security, and of course, transport of information was quite a challenge. And it's been addressed by the latest specifications of the OPC UA standard. So Microsoft is the first cloud-based infrastructure provider that addresses and solves that problem by integrating OPC UA in their Azure IoT product. And what I'm going to show you, I'm trying to click my way to the next slide, is the demonstration of that. Now, some of the relevant part relative to this architecture is the ability to run artificial intelligence at the edge. What that means is that decisions, critical decision, time critical or mission critical decision, have to be taken at the plant level. I can't wait for information to travel all the way across the cloud to some remote system, and then in order to wait for some control instruction to come back. So the edge devices are diverse in nature and are usually high in numbers. So I need to have a way to manage that infrastructure, especially from the IT standpoint. I have to be able to comply with internal SLA and all the security requirements, and that's what this architecture allows. And ultimately, of course, optimize the communication to avoid shipping out all possible information across the wire, and also enable the ability for user to make a real-time decision, like in the case of the alarm, in the scenario of the alarm. Now I'm going to switch to the demo slide, which it's rather easy for anybody to show, to actually experiment. And this is part of our training. We show people how to develop OPC UA solution, including cloud integration. So what we have here is the simulation that was created in conjunction with Microsoft that shows the ability of consumer information to control a number of plants geographically distributed in order to manage and monitor and measure the efficiency of the equipment, the OEE. I usually call it effectiveness, but there's different variations of the definition. The idea here is that I can have a good view of the performance of my plants across the board or across the globe, in this case. And eventually, if I need to drill down into specific problem that I see, I can go and look at the details about a specific production line, and within the line, I can further drill down into the machine or the equipment that is having a problem. And you can see that problem is identified being the pressure of this robotic arm. So this is a very traditional, if you want. There's nothing. I mean, the impressiveness is the ease of deployment of this solution. But in truth, the challenge again here is that how do I connect all these things together reliably and seamlessly? In order for this system to work, it has to be interfaced with a landscape of devices. And the devices have to be connected somehow. I don't want to have to think too much about how to connect the device if I have to take care of the infrastructure. So I decide to use OPC UA as an harmonizing transport. And here you can see that you have different OPC endpoint. And these endpoints are running on different operating systems, if they have an operating system, and definitely different addresses, and some of them, well, not in this case, but they could use a different transport. These simulators use the TCP, but OPC UA supports HTTP, HTTPS, and they all have to integrate into this solution. Not only that, I have to have the ability to add my own solutions, create gateways, meaning that I have to be able to deploy intermediary nodes that can coordinate and orchestrate the communication with those devices. If you need, once I develop a new device, I can onboard that into the infrastructure by just connecting a known OPC UA endpoint. So why is that relevant, the fact that we choose OPC UA? Because OPC UA doesn't just transfer data. It also transfers the semantics of that information model. If I'm looking at these parameters, for example, an OE calculation. Well, those calculations are based on factors that need to be aggregated, availability, performance, and quality. It's very impractical, not to say inefficient, to have those calculations performed at the end of the life cycle on the cloud side. You know, we know that we can have like an Azure SQL table that store all the information, perform the calculation, and then notify the users. But some of these information is better suited to be aggregated at the plant for two reasons. Because it's more reliable that way, and second, because that information might be needed to be consumed on site. So in order for me to have that, I have to create tags, you know, or nodes or items that actually have that calculation in it. So this is a key difference. You can do this because OPC UA allows you to model information not only to display tags, registries, you know, MQTT points. It's also taking those and aggregate that. And then only the aggregated information will travel across the cloud to feed the system that need. A system that doesn't need to monitor a temperature every half a second. But they need to know about the cycle time, energy consumption, you know, product counts. And these are the information that are aggregated at the edge. As you can see from this list, which is represented by OPC UA nodes, what we call the edge is busy making decisions. And this is just one aspect of it. You know, this is just to support the OEE calculations. So your OEE is calculated on-site and is maintained on-site. The analytics relative to a distributed performance or to statistics or to a preventive maintenance algorithm might actually happen in the cloud. And even those can be actually maintained at the edge level on the device, but performed by a machine learning service that is running in the cloud. So the distributability makes that system ubiquitous in many ways, and also the infrastructure way more flexible. Now you don't need to maintain a data server. You don't need to separate your networks. You don't need to establish security and firewalling rules. You just need to orchestrate your cloud integration in a way that suits your need. That is a definitely saving in infrastructure. A few years ago, we used to do these same things by renting data centers and putting blade servers in place, with large historians and web servers in order to deploy the similar information. Today, all these can run on microservices. It can run specialize containers to perform specific function, and then communicate it back and forth to the edge. Again, one of the key aspects of this solution, the Microsoft Azure IoT Hub, in conjunction with OPC UA, is that bidirectional communication. Command and control is something that is not easy to be attained when implemented in such a distributed scenario, let alone security and redundancy. So that's basically the end of my demonstration. And I'll take any question and I'll go into any detail you desire. I'm not looking at I think we have something in the chat, but I couldn't look at it. We'll probably keep our questions for the end. The last slide is in summarize of the points that we're making, that the OPC UA publisher is basically the OPC UA server. The hub is the coordinator. What we saw is one of the new services called the Time Series Insight that aggregated information and allows the analytics. So the last bullet point is a highlight of the command and control implementation, which is at this point rather unique in the Microsoft implementation. We did the demo. So in waiting for your question, I'll wait until Stan completes his presentation, and we'll take questions, and I can go back to the technical details.
Excellent. Thank you, Kaz. Excellent. Yes, I see we have some questions coming in. I'll be sure to get through this in about 10 minutes here, and we'll have plenty of time to get through all the questions. Because I don't seem to have control. There we go. Thank you. Sorry. So I just have a couple slides, actually just 2 slides about our OPC UA adoption process. And this is the thing we've put together to support OPC UA, OPC Foundation members and other companies that are looking to adopt OPC UA. It's really a complete kind of OPC UA adoption lifecycle from concept to certification. And I'll walk through each of the steps at a high level, but the first 2 steps are really the kind of go together package, the assessment and the roadmap. So a company that's looking to implement OPC UA in their products, they would be these 2 steps would be provided to really define the scope and the requirements. It's usually about a 2 to 5 week kind of exercise to go through both those first 2 steps. It includes 2 workshops. It's conducted with the product management and development leadership. Depends a little bit on the organization and how they run things in development, but typically those 2 parties are represented because we're really defining the requirement of OPC UA that match to their product goals. At the end of the first, at the end of the assessment and roadmap, there's actually a development plan as shown there at the bottom. Development roadmap, development plan finds all the activities, the development activities that actually prioritize backlog. So the point is, coming out of the roadmap, the customer is ready to start their first project, their first OPC UA development project. And of course, we have the other steps to support then what the output of the roadmap, what's in the plan. And if there's oftentimes training required, So we do have training, and when we get the end of the presentation, we'll share the training that we currently have scheduled, but we can also do customer-specific training on premise, that sort of thing, to help ramp up the developers in preparation for the development. And we also provide the development services, and that can come in different forms. It can be completely outsourced, and we can do the development with our development team. We can collaborate and develop your team if you want to develop the expertise in-house and work with our development. We can do it in a collaborative way, or we can also do kind of an oversight where we're overseeing the development, sure that the OPC is being implemented in such a way that it'll be certifiable at the end. And then, of course, the step is the certification, and we can be there to help bring the whole requirements portion as well into development to make sure that the solution is certifiable at the end, and also help to organize and prepare for the certification. And there's a certification test tool that we can walk you through, and things like that. Really just streamline the whole certification process, which can, if not done properly, can really take man resources. So the whole goal of the process is to help customers more efficiently adopt OPC UA, move through the process faster, less risk, and of course less cost. So that's the kind of the overall of the process. I just have one slide focusing more on the assessment. Again, this is a 2 to 5 week kind of exercise, depending on the customer and the speed they're ready to move in. It includes 2 workshops with the customer. Duration is just dependent, but usually in like a half-day type of workshop. The assessment, we go through a kind of a high-level architecture review and assessment, understanding what the customer's goals are, objectives for OPC UA, why they're doing it. So we establish a better understanding before we get into the specifics of OPC UA. And then we have a large spreadsheet we use as a tool. It really maps or prioritizes all OPC UA features and options. They're called conformance units technically, but basically it's all the capabilities of OPC UA. And the idea is through the spreadsheet and through the workshop discussions, we select and prioritize all the applicable features that will be implemented for the given product. There's, again, it's very large, 377 possible options, features, and typically it's some subset of that. Also shown on the screen there, kind of in the middle of the first block, the UA assessment. That's just a part of a screenshot of the certification tool, which gives you a nice mapping of all the features that belong to a given profile of an OPC UA server or client. And we use that tool as well through the process. And the end result of the assessment is a raw backlog of development. So basically a list of development activities. And of course the assessment itself, the spreadsheet that's prioritized options, features to be implemented, which is really the scope and the preliminary raw development backlog is coming out of assessment, which then becomes the input to the roadmap step. And again, we prepare for the roadmap. We organize all the backlog, put estimates and things against all the development tasks. And then in the roadmap section, again, another workshop with the customer, we walk through the development backlog, prioritizing the development to align with the priorities of the features and functions that are desired in the product. And coming out of that is kind of a high-level release plan or release roadmap of releases based on usually like themed releases, maybe an app platform independent release, for instance, or a security release, whatever, what makes sense aligned with the priorities of the customer with their product. And then ultimately a development plan, which really defines the schedule, with estimates of efforts. It's an output that can be used for going right into the first development project. So the goal of the 2 steps is coming out of the roadmap. You're ready to start a project. You're ready to start developing. So that's the step process. And without going into great detail at this time, I think I'll leave it at that for now, and we'll move to the Q&A. And we do have a little over 15 minutes, which is good. And so please, did I do that, Kaz? You can go to the last, look to be moved. Take us back. We went too far. Yeah, got into the, if you take us back to the Q&A slide. Not sure if I did that.
No, I think I just clicked it accidentally, and there it goes.
There we go. Okay, so yeah, so I'll leave this up. Oh yeah, so I'm going to leave this. You can see development actually, our training, and you can go to our website and see the training. We didn't post yet, but we're just we're going to be adding another training at Milwaukee, which is going to coincide with BC Foundation's seminar that's hosted at Rockwell. So we will have 3 trainings offered, and they're all coordinated with seminars. So they're all alongside Foundation seminars. So you can check those out and register if you like. I'm going to throw up the poll right now for the webinar. I'd appreciate if you take the time to provide us some feedback on the poll. And with that, I'll open it up to the questions, Q&A, and we do have a couple questions here. I would like to hear more about performance, since that is an issue when you are dealing with thousands of nodes. Kaz, you want to respond to the question?
Absolutely, yes. That's a question by Dennis. And so the one aspect of this kind of integration, and that's one of the reasons why we are looking for edge side implementation, is just that. We can't afford a latency for some of the decision making or mission critical aspect of the integration. Therefore, these and probably I should better let me just go to this slide instead. I'm gonna forgo the demo. So unfortunately the slide activated. So let me just there you go. So the performance is, I wouldn't use the word guaranteed. You know, there are trade-offs, of course, when the system is so distributed. But there are 2 aspects of it. One is that the system is intrinsically scalable. A lot of calculations, a lot of intelligence, even, you know, they call it artificial intelligence or machine learning, but there's a lot of logic, if you wish, can happen already at this level, and it can be decision can be taken at this layer here. Then you have this gateway. This is basically a service that aggregates all the endpoints, all the servers in this case. So that guarantees the fact that these devices here, you know, which eventually refer to these, are constant. Yeah.
Sorry. I don't know if you're still showing Q&A slide. If you're trying to show something else, you're
Oh, thank you for saying that. I have There you go. So what I was gonna, hopefully the thing is now visible.
Yes.
And let me just take that back. So logic and calculation are taken at this level. They are somewhat aggregated as an OPC UA server level, but they are coordinated by a gateway. So these gateways are the field gateways. There are on-site services that run, and they make sure that the communication with the OPC UA servers is healthy, ongoing, and if it's failing, it can fall back to some other nodes. Then you have in this case, the Microsoft side of the Azure endpoint, which is the IoT hub. And the IoT hub is something that is deployed in Azure, and you can deploy as many as you want, and you can geographically distribute them in the several data centers. I think there are probably 5 major regions, well, more than that actually. There's East and West US, Northern Europe, Southern Europe, and I don't know all the data centers that they have. So you can strategically deploy your IoT hub to guarantee the distributed communication at that level. But when you are at this, when you're operating at this stage, well, I would argue that you're not taking control decision. Meaning, a command and control procedure can come in this direction, but command and control procedures are, for example, the starting on a work order, not whether you had to stop a reactor because it exceeded the safety limits. So again, the infrastructure will take care of the performance, and it's just a matter of good planning and good design. One other thing to remember is that we starting with, in the case of Microsoft, starting with Windows Server 2016, technically you can deploy Azure on premises. So, we are talking about cloud integration for convenience, but this is something that can be, if performance is a concern, you can control it by your own data center. I don't know if that answer, I mean, we can have like 2 hours only of performance. I don't know if it's satisfactory enough at this level. I think I have to look at the chat. I think somebody's chatting, probably Dennis. No. Okay. There was another question from Dennis about security, I think.
There was, yes. Do you want to speak to that?
Yeah. So the Dennis also asked to cover a little bit more about security. Now that's can be an extensive topic too. I'm gonna navigate to a slide here just for convenience. And OPC UA security. The one aspect, and we go into details during our training, security is an often misunderstood aspect of OPC UA. OPC UA defines the specification and the implementation and the certification and the validation. It's not just a standard on paper. It's a reference implementation how to do it. But the algorithms to use and the way you actually enforce and implement security, it's basically up to the user, one aspect, or up to the capability of the device that the OPC UA implementation is running on. So there are different levels of security. But there are 2 important aspects. One is the authorization of the users, and the other one is the authentication of the system. So the 2 systems, like in this case, a client and a server, in order for them to even establish a channel, they have to exchange a trusted certificate, more or less like you see in the common web standards. And in doing that, OPC UA adopts similar strategies like the X509 or these kind of certificates. For those who are familiar with the .NET framework, it looks like a .NET certificate. It's not necessarily only .NET because it has to be multi-platform. But the 2 systems will certify themselves to each other. And then once that channel is certified, is validated at the level, then there is a user profiling in which the system has to authenticate the users or certain aspects that the user has been profiled to access or not. The one thing that makes all these more manageable is the discovery services. And the discovery services are the part of the standards that ensures the fact that your OPC UA implementation is manageable from one central point, either locally or globally. And Microsoft just announced last week in Boston when we were having the roadshow the release of a Microsoft Azure-based global discovery server implementation that will allow IT management teams to manage the certificates and authenticate and authorize both users and applications from a central administration point that is not necessarily deployed on site. So again, we can talk about the algorithms that are in use for the security enforcing and the ones that are being deprecated, but we get into the SSL discussion and more so. But again, the security is enforced at different levels, and it can be integrated to the most famous LDAPs, Kerberos, Active Directory, and all the infrastructure support. So, Tom Burke. Yeah, Tom Burke is pointing out.
Yeah, so this is Tom Burke. So one of the things actually we have on the website, on the foundation website, is a lot of different videos that are on our YouTube channel. And we've got a pretty in-depth presentation we've done on security. And I would encourage you to take a look at that. We've got a high-level one, and then we've got a kind of a detailed one that goes through a lot of the stuff. Obviously, you could download the security specification as well, and but it's a little bit of it'll help you fall asleep at night. Let's put that, because it goes through all the details. The other thing about performance is the task is to make sure that the OPC specifications aren't the least common denominator. I mean, my whole focus is to make sure that we have the highest level of performance possible, and at the same time provide really robust, reliable interoperability. So there's a lot of details, and Kaz mentioned a lot of the stuff. I mean, when you think about a lot of the profiles and things we've built in the architecture, you can turn things on and off depending on what your requirements are. But our whole focus is to provide enough of the technology that really makes it secure and at the same time achieves your performance expectations. So with that, Kaz, that's pretty much what I wanted to add.
Thank you, Tom. Or short than that, also, you can come to our training and learn all about implementing the security aspect and the performance benchmarking.
Yes, and also, as you can see on the screen there, you can also visit our events page, and we will be having more webinars and on different focus topics. I'm sure security good topic at some point. So we try to hit a lot of the most important topics. I have another question here from Ken. It's kind of a two-part question. How do you develop connected devices, and what platforms are supported at the edge in the cloud?
All right, I can take on that. The one thing that we didn't ask, how many developers are there. I'm gonna show an ugly screen. It's ugly for some. So the one aspect, how to develop the connected devices is you pick a language of your choice, a platform of your choice. The system is there are certified implementation. And
Kaz, we're not seeing your screen. I mean, we're seeing the Q&A slide again.
Yeah. So you can choose your language, your platform. I don't know of any Haskell implementation, but the usual suspects are there. The one screen that I'm showing you, for example, is one of the servers that is used in the Azure demo is developed in .NET Core, running on Linux, and you can see that my virtual machine is editing that code. So the platforms are the .NET, C, C++, Java, and you have the OPC reference implementation. You have a number of SDKs. We go through different languages in our training just to show that versatility. Also, OPC UA is designed to run on embedded system. So the presence of an operating system is not necessary. So devices, control devices or actuator can actually run on real-time operating systems or bare metal implementation. And usually in that case, your choice of language kind of narrows down to like C, C++, and those kind of languages. But OPC UA has been around long enough, and as I said, the code you're seeing on the screen that is partially used for this demo it's been done, of course, in .NET, and the .NET implementation went through a tremendous refresh by Microsoft that really redesigned and redeveloped the stack with a new specification, and that's actually available on GitHub. Let me just go to this again.
Okay, we have a couple minutes left if there's any more questions.
This is Tom. I see that there's been a lot of questions that have been asked about certification, and I think one of the things to do, and the reason I'm partnering with like Beyond, is really they're providing the fundamental, training and infrastructure and consulting services to really help our companies, get certified products. So wherever you are, as Stan talked about in the development life cycle, I highly encourage you to, partner with my friends here and really have them, provide the necessary, training and consulting services so that you can quickly bring OPC UA certified products to market.
Excellent. Thank you, Tom. It's a very good point. And I know it's quite on a lot of people's minds. Well, we're at the top hour, so that's the end of the scheduled webinar. I think we answered the questions that were coming in. So with that, I'd like to thank everybody for joining. And again, we'll send out an email with a link to the recording and also the presentation. So you will have that after the webinar. Thank you very much. Have a great day.